Great. I think we are live. Can you hear me?
Yes.
Great. Let's get started. This is our last lecture on Python. So get started. Oops. All right. So week 8, we will. Okay, hold on. Talk about the new programming paradigm. So far, we all, experienced programming, like we call it procedural programming, where you start from top to bottom, you have some branching loops and some functions, right? So from this chapter, we will talk about another way of thinking about programming is called object-oriented programming. And so basically what that is, in a nutshell, is to combine the functions and variables in one entity we call the class, and then we use that as a basic programming unit, as a module, and design the relationship between those classes and how to interact with them. So that's in a nutshell, and let's get started. Where's my let's see here. All right. Next. So everything in Python is an object. You probably are not aware of that, but in day 1 of lecture, believe it or not, you're already using object, like integer, float, string. What else? All these primitive data, and of course, list, dictionary, and tuples. These are all objects in Python. Every object has a type. You can use type function to get a type of object. Okay, so these are built-in objects in Python. Okay, and what object is a data abstraction that will capture internal representations through the data attributes, like for example, if it's a Python string, and string has a lot of it's basically it's a collection of characters, right? And of course, you have a length function. You can sort them. You can capitalize them. There's a lot of function that you use on string. You have used a couple of them. These are the objects in string, okay? And you can interact with those objects, like get the substring out of the entire string, and do a lot of order and sorting and stuff. Okay, so these are the not custom, but built-in objects. You can create them as many instances of string as possible, like and list and tuple as well. And you can also delete them, like destroy an object. Python will, when it's deleted, will reclaim the memory space for those objects. It's called garbage collection. In C++, you have to manually delete them. So the responsibility of memory management is upon the shoulder of programmers. For Python, Java, those kind of language, or C#, you have by and large a garbage collection to do that. So you delete them and can forget about them. All right, standard data objects like lists, tuples, and strings, like I said before. Now, today, we're going to talk about how to create your own data object types using class, okay? So when you're using an object like a list, you don't necessarily care about how this object is implemented internally. For example, if you have a list of 1, 2, 3, 4, what kind of data structure you can represent the 1, 2, 3, 4 internally. What do I mean by that? Well, this is like, for example, here is a list of the 4 numbers. In this particular case, you have a number and with a address to the data in the next number in the list. And so each number will know what's my next number and next number and next number. By doing that, you can chain them together. This is called the linked list. You can just follow this kind of like pointer to the index for the next number, right? And then using that data structure, then you will code a different method to retrieve the ith element or from ith to j element and so on. And you know, depends on the internal representation, how you implement length function, minimum, maximum, daily function will be different, okay? And so the idea is, one of the object-oriented programming idea is the internal representation of an object should be private, meaning user shouldn't need to know how this internal representation is to be able to use it, right? And all this behavior can be modeled internally, use something called interfaces, where it's like a function signature, and you just need to know how to use this function. Like those, you already experienced, all these length function, minimum, maximum are pretty standard across all our containers, tuples, and strings, and lists, right? So these are power of a good API. We call the API or interface, where you can just, everybody knows publicly how to call them, but you can free to change the internal implementation of that, okay? And once you create it, so for the custom objects, right, how to create them? We use, we need to make a distinction between create a class and using an instance of the class, right? So create a class, you need to first define the class name. For built-in, somebody else need to define and import into Python, right? So you have to define the class name, you have to define the class attributes. For example, you can implement your own list class, right? So you don't need to use a built-in list class. And to use it, you can create a new instance and doing operation on them. For example, we can say L equal to 1, 2. That's a particular instance of the class list. And then you can get the length of the list. So classes is like templates for building houses, right? Like blueprint. And individual instance is like you building an individual house according to the blueprint, right? So why we use object-oriented programming? Well, we can bundle the data and method together into one package. That way, it's really natural for human to do that, right? Of course, for example, in a lot of gaming industry, right? You typically, like first-person game, you have hero, you have adversary, you have boss, right? Those kind of things, and everyone has some common attributes like health level and number of weapons, money and things like that to belong to each individual player. And then once you interact with other enemies or other people in the game, your attributes may change, right? You may gain some values in one position. You can lose some health values when in a battle and stuff like that. When you get some medication, your health value may go up. So those kinds of things are natural, pre-expressed in object-oriented programming, right? In your project, final project, you code a text-based game, remember? So I encourage you to use object-oriented method to rewrite your code. See if you can encapsulate those things in those kind of new method. All right. So how to define your own class or own type? Well, just like define a function, you use a keyword instead of function, instead of def, you use class, lowercase class, and then followed by the name of your custom class. In this case, I give you example coordinate and with parentheses. And in parentheses, you can put optional object in it. It's called basically that one is called parent. We'll talk about that later, right? So each class belongs to the object in Python. So in modern Python, you don't need to put in anything. It's just the empty parenthesis. But if you have a parent, we'll put parent class name there. Okay, and then followed by the colon. And then you have some indentation, just like when you define a function or try else block, and then put all your attributes like the class variables and methods there. All right. So basically, the object means it's a Python object and inherits all the attributes we'll talk about later. So there's some terminologies. Coordinate is a subclass of object or a child of the object, and object is the superclass or parent of the coordinate class. Okay, so that's some nomenclature. What are the attributes? Data and procedure that's belong to the class are called attributes. So when you describe an object, right, a person or animal, you may think, oh, this animal has some object like how many eyes and what color of eye, right, and what the animal can do, like how to speak, how to dance, how to eat. These are kind of actions. So think about data as nouns and function it as verbs. And internally, inside this object function, we call method. Sometimes you'll see that, right? Because it's attached to that particular object. And in our example for the coordinate, you can define as many points in the plane as possible. Which has coordinates x and y. You can Cartesian coordinate, and then you can calculate the distance maybe between objects. So let's implement that such a class. First of all, you have to define how to create a class, the template or the blueprint, right? So to do that, it's it's a convention to have on double underscore init double underscore as your function name for this, for this we construct function or special method called init function. When you create object, this init function is being called. That's all, right? So init function helps you to set up the attribute and set up the house, right? And in there, the init function, okay, inside the class, you need to add a special parameter in addition to the regular parameter that you're going to use for regular function. That special parameter is called self. Well, you can call it anything. Rather, it's a convention to use self, but you can use this or that, or rather anything that's not a Python built-in keywords, right? So, so that's that. And this self is used to refer to that instance of the class when you use that class to create object, right? So when you create 2 points from these coordinates, the points may have a different x, y, but more importantly, how to refer to the object created out of this template, you use this parameter self, okay? When you call the function, you don't provide the self as argument, but when you define it, you need to put a placeholder there because it's actually supplied by default, okay, when you call it. So you don't need to explicitly pass in that one, but I will show you later. So and once you attach the attributes, you want to use self dot y, right? So that's the 2 data attributes for every coordinate object. Okay, so this is where you use self, right? Self means the object, and then this x and y is called instance variables. Okay, and that being assigned to these the value supplied. Okay, so that's init function, right? Every class you typically you need an init function and maybe a couple more, right? So how to use that? Once you define this custom coordinate class, to use that, you can just initialize that by calling this class name parenthesis supplied by an argument required by init function, right? In this case, x and y, these 2 parameters. Notice that you don't pass in a self into this when you call that class, right? Because it's implied. It's automatically supplied by Python. Okay, you just need to put in the initial variable x and y. Okay, you can create another point called origin, and it's coordinate 0, 0. So C and origin are both instances of the class coordinate, but they are different, individuals. And you can print the attribute by using the dot notation. Right? You see a lot of dot notation. So this case, it's the dot notation for the attributes. You can also use dot notation for the methods and that. All right. So again, like I said, the data attributes of the instance are called instance variables. X and Y are instance variables. And when you call this, don't provide the argument of self, Python does automatically. Okay. So it's better to visualize this again in pythontutor.com. But again, before we do that, just think about visually in your head that whenever you call an instance method or attribute, that attribute is attached to the frame of that particular instance. Right? It's a separated scope than origin, instance. So this X is totally different than this X. They refer to a different memory space. They are attached to a different frame for that object. Okay. And then we define some attributes, how to define the method in the class. The method is basically a function that only works inside the class, attached to that class. Right? When you write the method, don't forget you need a self as the first argument always, but when you call it, you don't supply it because they know which object is it is. The calling object is the self itself, right? Python knows that, so you don't need to supply it. And that, like to get the attribute, you can use a dot notation to get the method, to call the method. All right. So dot operator can access the data attribute and also can access the method. Okay, so here is an example of instance method where you define this function called distance. Basically, you want to calculate distance between 2 points, right? And now the self refer to any instance starting from 1 point, and other refer to another parameter. In this case, it's also a type of coordinate. So you have 2 points. One is the point itself, one is the other point that is supplied by calling the function. So if you call c.distance with origin, you are asking for calculation the distance between the point C to the origin. And the way you do it is by Pythagorean theorem, right? So you'll have the origin and the other point. These two referred to by self and other, and their x and y are different. So you have a delta x square and plus delta y square, and you add them, and square root of that is the distance. Okay, so this is a Manhattan distance, and that's the whole function, right? So other than that, the special self parameter define a method is exactly the same as define a regular function, except that function is attached to this class, not a independent freelance function. Okay, so that's that. How to use the method? Well, once you define it, you can do this, right? So you define a point C with the coordinates 3 and 4, and then you define a point origin 0, 0, and the distance is C dot distance. You're calling that method with the origin as a parameter. So the origin is being assigned to where? The other, right? And where is the self? Well, the self is the C itself. So the self has a coordinate 3, 4, and origin has a coordinate 0, 0. And when you pass that to this function, self x is 3, self y is 4, other x is 0, other y is 0. Okay? So it's actually equivalent if you do this, right? You use a class name, coordinate, dot, distance. Remember, this coordinate is a class name, not object anymore, not instance of a class. So in this case, it's a class method. Then you have to supply both coordinates, C and origin. So in this case, C and origin are in equal footage, right? Equal distance, equal position. So the way that you can get away from only passing one parameter is because this is instance, so the self equal to C. Here, there's no self. This is a class. So you have to supply two parameters. C is one instance and origin is second. So bottom line is you need the two instance as a parameter. Here, the first one is implied. Got it? So this is the difference between using a object to call that method versus using the class method to call that object. Because a class is not unique, right? It's the template, it's a blueprint. There's only one blueprint. Like you print monies, but you can't print money. Well, you have a template and then you can print money. All right, so here you go. So if you want to define this coordinate, you can print that and you will see some absurd description of that object. Coordinate object at this, what is this means, right? This is a address for the memory space where this object is allocated. Now, this may seem a little bit daunting or not user-friendly for the user. So you can actually define your own string when you do a print C. The way you do it is you define a special function in that object class called _string _. If you define that, then when you print that C, it will print whatever you defined. So here, like 3, 4, this is much more intuitive. So let's define that. So basically, you define this function or method. Okay. Now don't forget you have to pass the self, because normally this will be a non-argument, zero argument function, but because it's inside the class, you need to supply it at least one, which is self. And you return this angle brackets and the x comma y coordinate plus the right angle bracket. So that's the string that you're gonna return for that special method string. Once you define that, when you call this print, it will print your own defined, string. So that's another special function inside class. There's many special functions for a Python class. Init is the, start of everything. Like you give birth to a object, right? So this is like birth certificate function. And then this is how to describe the name of that baby. All right, so when you ask for the type of a custom object, it will give you that class name, right? Which is the type. You are defining the custom type, essentially. And then you can use is instance function to check if an object belongs to that instance of template coordinate, right? So in this case, C is an instance of coordinate. This is useful when you want to know what type or if that object is a type of coordinate. Now, there's many other special functions. So remember, when we talk about strings, right, we can show you that two strings can multiply together, not two string, I'm sorry. A string and a number can multiply together. And that meaning is not regular multiplication, it's basically concatenation, right? Like for example, it's like special, string special times 3, you will print out special 3 times. So how to define a different behavior than normally arithmetic operations? Well, you can override. We can override it by define these functions. Previously, by defining a string function, we override the default behavior of how to print a custom object. But now you can have much more, right? This _add, subtract, equal means equal. So when you define these functions, you are actually overriding how to do when people write add a plus sign, minus sign, equal sign, less than, and greater than, etc. And even you can even override the length function and print. String function is for print. So by defining this function, you are telling those operators that when you are operating, when you insert this operator in front of this custom object, then find this function to look for how you're gonna do with that, right? For numbers, it's clear. Usually, you don't need to define a special function, but for your custom object, Python has no way to know how to proceed. You have to tell them what's the definition of those operator again. So to be clear, let's take another example. Say you have a custom object fraction. Notice that function in Python, you have floating number, you have integer. You don't have fractions as a number. You even have a complex number built in, but you don't have a fraction. So let's build a fractions. Okay, fraction is a new type, so we can use that as a class name. Internally, we want to represent a fraction with a numerator and denominator. That's the two internal class attributes. And then how about interfaces? Like what kind of operation you're gonna do from the fraction number? Well, you can print the fraction. You can add, subtract the fraction, maybe multiplication, division. You can convert a fraction to a floating number. So these are the methods that we'd like to implement for the fraction. Okay, so first of all, you define a class called fraction. Normally, we use a capital letter for class name, right? Yes, so this needs to be capital lettered. And then object is just a common referring that this is a top level, almost top level class. So init function, remember, it's how you give birth to the fraction. You want to set up the number. So basically, don't forget the self. And you need two parameters, like numerator and denominator, and you can store them into memory, internal attributes, and for later usage. So these numbers, numerator, denominator, belong to that instance of a fraction. Every time you start a new fraction, these number changes now, but that's in a different memory space, okay? And then initially, we're just gonna define how to print a fraction in this string double score function. Basically, it's just a string representation of numerator / denominator, okay? All right, so now let's use that. 1/2, define this first fraction, assign fraction 1 and 2 to 1/2. So 1/2 is essentially pointing to fraction 1/2. 2/3 is 2/3, right? And then when you print it, it print 1/2 and 2/3. So just like what you define here. Numerator / denominator. Numerator / denominator. Got it? This is how to use that, right? Suppose Python already had the fraction defined, and you can just direct use it, right? Think about this like float, complex number. Okay, so we have good implementation so far. Now, there's one technique we call getter and setters. So for the object-oriented programming, there's a principle called you open for implementation, for extension, and close for the interface. So basically, what I mean by that, you can later on modify how you implement the API, but once you define the API, you better settle down. And you want to hide your internal representation of the class to the user. So you don't necessarily need to give them access to or let them know what's the variable you use to store numerator and denominator and how you store them. That's totally irrelevant. You can give them the getter method so they can use get numerator to get that number instead of calling self.numer. Although Python don't prevent them from doing that, there's no way to hide them. In Java, you can define private, protected, or public or package level attribute to protect your attributes. But in Python, there's no way. Everything is public, right? So you can't hide them, but it's discouraged to use the attributes directly. You can use this function to return attributes. Why are we doing that? Well, if in the future version, we decided to use a different naming convention for those variables, we don't necessarily need to let the user know because they just need to call the same API. The API will never change, ideally. All right, so we have defined a fraction custom object or a class. So we can say get numerator. This is a procedure. Don't forget the parentheses. You get 1. Get the denominator, you get 3. Okay. So now let's add some new method. Let's say how to add 2 fractions. Okay, this is how to add 2 fractions. You define this on __ add. Notice that you need another parameter of the other fractions, then you can add, right? Add self to the others. So the way you do it, well, in grade schools, you know, you have to make the denominator the same by cross product, right? So the one denominator multiplying the numerator of the other one, that's your new denominator. So you make them the same. So basically, it's the numerator. The denominator is the other denominator times the self not a denominator. Wait. Yes. So you have to multiply the denominator, and the numerator is the denominator times the numerator for the other one, and plus the other's numerator plus yourself's denominator. So it's cross product for the numerator, the new numerator, and that's the new fraction that you're going to produce with the new numerator and new denominator. Subtraction is the same thing, other than the numerator has a minus sign here. So now you define the add and subtract. So when you use it, you have 2 fractions created. You can just say the new fraction is 1/2 plus 2/3. Now you get 7/6. Any question on that so far? So by defining this function add in the class, you redefine how the operator behaves when you add the 2 custom objects together, right? Isn't that awesome? So yeah. And then finally, we want to convert that to floating. That's easy, right? You just using Python internal floating number division, you get floating number, and which is 1.16 here in this case. Okay, so we have given you 2 examples, right? One is the fraction, one is the coordinates. You know how to use that to define attributes and method. Let's look at the 3rd example. I want to define a class that represents a collection of integers. It's like the set, right? So what's the difference between set and list? Now, keep in mind that set exists in Python internal, but we want to define our own set, okay? So it's all about the custom objects or classes, this class. So initially, the set or collection of integers is empty. Now, okay, think about how you represent that, right? A particular integer appears only once in a set. There's no redundancy in a set. Okay, so that's the hard requirement. How to use the internal data representation of a set? Well, you can use the list to store the elements of set. How to define an interface for that set? So think about how to do sets operation. You can insert numbers or elements to the set. You can check if a element is in the set, right? A Boolean value. You can remove element in the set. Okay, these are the interfaces. Okay, so how to define it? Now, first, we don't forget this class keywords and integer set. And then the init function will set up the internal instant variable called we decide to use empty list to represent the set values, okay? Now let's do another thing. So let's define a string, and basically I want to sort all the numbers in the set, okay? Now, the way you can refer to that because across different functions is because this value is shared between all these functions and it's in the init function. Okay, so initial result is empty, and if there is an element in the set, then you add that element to, and with a comma to the empty set. And then at the end, you print all the elements but one in your result, and that's the string. When this, so what function are you gonna call to invoke with this string function? Well, it's a print, right? When you print that, it will nicely sort your values and print all the numbers in the set. Okay, how about insert? But to insert element, first of all, remember that the invariant, a set, all the numbers or the elements in the set is unique. So to satisfy uniqueness, you have to manually check if the element you're gonna insert is not already in that internal representation of the set already. If not, then you can append that value to the empty or existing internal list. Otherwise, you just ignore it because sets don't allow duplicate items, right? How to tell an element in set? Well, that's easy. You can just say, if is E in a list, you can use that in operator. And how to remove an element from the set? So you call the list function remove. But sometimes it may throw exception because that element may not exist. Well, if that's the case, you catch it in the exception clause. Says, I want to raise another error called value error, and it will give them the hint. So I will give them that the string representation of that element is not found in that integer set. Okay, so that's the function remove. Any question for that? The key is to use the values empty list as an internal representation. So here's an example how to use it. First, initialize a instance s, which is the integer set, and the print that is empty because initially nothing happened. And then you insert 3, and then insert 4, and then insert 3 again. Now you print, get 3, 4. Where's the actual 3? No, it's a set, so you can only get once. Okay, continue. If I want to insert number 3, 4, 3, and I want to ask if 3 is in the member, the answer is true. Why? Although you're throwing it away, actually you ignore the second 3 being inserted. That's it. And is 6 in the member? Of course not. Okay. For integer set, you can insert 3, 4, and some other redundant number and remove it and insert another number. You can print out. So only 4 and 6 are printed out. Okay. And then once you've done that, if you remove 3 again, it will say 3 not found, value error. Okay. So be careful. All right, so these 3 examples are pretty straightforward. Hopefully that will help you to understand what you just scratch the surface of object-oriented programming, but at least you should be able to understand when other people's code when they're using class and object. The key thing for you is to understand and read the other people's code and maybe implement on your own as well. Again, to recap, object-oriented programming, you can bundle together objects that share the common attributes and procedures and operate on these attributes. It's very convenient. And there is a distinction between how to implement an object and how to use the object, class versus object, right? You can also, we haven't talked about here, is you can also use a hierarchy of objects, right? You can create a common base function or object, and then on top of that, you can spawn off a child object that inherit everything of the parent, but add more. That's the power of object-oriented programming. Okay, and better yet, you can create your own class. Okay, so that's a really awesome thing to do. So here is another recap. Implementing a class versus using the class is totally different. It's writing a code with different perspectives. So implement a new class, you need to define the class name, maybe a init method and some more. Okay, method and attributes. How to use it? Well, you initialize a object, you create instance of the object, and you operate on them. A class, by creating a class, you basically create a custom type. Like a coordinate is a class. Also, it's a new type, right? It's defined generically, and you can use self-refer to any instance while defining a class. And class will define the data and a method common to across all the instances. Instance, on the other hand, is one particular object, right? And it's birthed by the class template. And between instances, the class, the value could be dramatically different. They are not related to each other, other than the number of parameters and the name, maybe. But the value is oftentimes not the same. Even though they're the same, they belong to a different object, okay? So why use OOP? Like I already mentioned to you, it's very natural for the human to use object in the everyday life. So why not use that in the programming, okay? And you can group all different type of classes into the same type, okay? So to define a class cat, you may want to define the name, the year born, and the color. Okay. So again, to review our previous examples, a class has data attributes and procedure. The data attributes, you can represent the object with data. For the coordinate, it's X and Y. For the animal, you can give the name and age and skin color and other things. And then it's a bunch of methods. Like for coordinate, you can define a distance. For animal, make a sound. Okay, so here is a recap. Right? Animal class. You can define age and the name, and then you can birth an animal with 3 years old. Okay, you may not need necessarily all give a name for now, and then don't forget the best practice is to set a getter and set a method right away. So when you want to use that outside the class, you have it, right? Rather than calling the self age, self name, which is frowned upon, okay? And internally, when you define the internal function, you can call the self name, self age. But when you call it externally outside the class, use the proper way by using get and set method, please. Okay, and remember to call the method of a class, use dot notation. This is the age of the attribute. This is a age get age procedure. Okay. So I already talked about this, right? So the reason you want to get method is that the internal representation of variable name can change. You may later on want to change that to self.age, but when you want to ask the external customer to call your function, you don't need to change that, right? All you need to do is change this line of code. Instead of self.years, you can change it to self.age. And I'll already tell you that Python is not great in self-information hiding, which is a key concept for the object-oriented programming is, hiding the information, right? You don't want to let people know the implementation details of your class. However, Python has no way to do that. You can easily just print out these attributes. You can even change them outside the class. Okay. You can also even create a new attributes that's not defined before. However, these methods, these way are frowned upon. It's not a good Python style, so never use them. Right? Python don't forbid you to use them though. And when you're calling the method for a class, don't forget you can, when you define it, you have to put a self in it. But when you call it, you don't. Okay. Yeah. So I don't know if the Zile books talk about hierarchy, but I want to show you quickly an example of this is another good way to experience object-oriented programming. So basically, I talk about like parent and child class. So you can group all the ancestor trees. Like if you want to define a student, right? Student belong to a person class belong to animal, and there's a bunch of other animals in parallel. So that's the hierarchy of classes. When you define animal, you can define some basic stuff, right? And then when you define person, you can just define the extra stuff, that's different in addition to animal class. And you don't need to redefine a copy over whatever you already set up in animal to the person. You can just add on, and student you can add on as well. Okay. So the child inherit all the money from the parents. Oh no, all the data from the parents, right? And you can add more behavior to it. So here is the example. Animal is a top level class, so that's why the parent is object, right? All the class is parent is object, very generic. Okay, so I decided to define age and name. All animal has age and name. There's no immortal animal so far. You can have a getter and setter method and return a string. Animal is the name plus age. Okay, so that's a basic animal. And if I want to define a cat is an animal. So you put this animal in that constructor or parenthesis when you define a class. That means cat is a instance or inherited from animal. It has all the method animal already defined. So the cat also have age and name. So in addition, I want to say cat can speak, meow, and the way you print a cat is different. So I want to override some and add some new function. We can all do that. Clear? This is addition. This is addition function. Additional function you define. This is override. Now, keep in mind this function only belong to the cat level or the child level. The parents don't have the benefit, right? So if your child can speak, the parent may not because there is no speak in the parent. Okay, that should be clear. And you may ask, where is init function in the cat? Well, it's not missing because init function is inherited from the animal. So it's shared the same init function, right, with the child. Okay, so here example, right? Once you define a cat, you can define some instance of cat. Like Jelly is 1 year old, the name is Jelly Belly, and you print Jelly, it will print the cat column, the name and age. And if you print animals, string function, it will print the name, however, the name and age, however, the tag is animal. So basically, you are using animals representation, not the cats. And then you have another animal called blob, 1 year old. See, this one it has no name, right? It didn't define a name. That's why the name is none. But later on, you can set the name. And then when you print again, you can, you get a name. Okay, so you can change the attributes. Okay, so here is a inheritance, right? Rabbit and cat all inherit from animal, but the difference is rabbit speak differently than cat, right? I don't even know rabbit speak meep, did it? So that's the difference, okay? So now you have a new animal called rabbit, 5-year-old, and you will say Jelly speak, Jelly is a cat, so it's female. Peter is a rabbit, so Peter speak meep, right? When you call this, it will call individual child class, right? Because the animal, the common ancestor, the animal don't have a speak function. If you call blob speak, which is animal, it will give you attribute error. It says animal object has no attribute speak, and indeed, it does not have it. So now some people may encounter that you have the same method in both the parent and the child class. Then which one is going to be used? Well, if you have a method that exists in the subclass or the child, it will be executed first. So whatever your current class is, it will be used first. If not found, then you look for the parent class up in the hierarchy. If your parent don't have it, go to your grandparent and go to your grand-grandparent and grand-grand-grandparent and so on. And at the end, everybody is the object, right? Okay, so for example, in the person class, right? Person is animal, but it has much more than animal. It has a name and age. I also can create a friends in person. So it's a list of person, right? These are the adder function. If you add a friend, add a friend, and you can just add, just like the list function we speak earlier. And the person say hello. Oh, there is a new method to give age diff in a user-friendly way. So the different age is basically my age minus the other people's age, right? If my age is greater than the other people's age, I will say mine is older than you. If it's the other hand, then the other hand is less than you, I will say it's how many younger than you. Okay, so that's the distinction. And then finally, person has its own method. So here is some example, right? Eric and John are person, and 45-year-old, 55-year-old, and Eric can speak. Eric can do the diff in age, and it says Eric's 10 years younger than John. If you do the other way around, we will say John is 10 years older than Eric. Depends on who is the self, who is the other, right? Got it? And finally, I can have a student that's a with a parent person. So in addition to everything that person has, the student has a major. And then in the speak function, I can randomize what they say, right? By this random function. So if the random function fall into less than 0.25, I'll say I have a homework and I need to sleep, I should eat and watching TV. Depends on the randomness, you may have some different to other, okay? So here is some example. Fred is student, 80 years old, and the major is cos 6. You can print Fred, and I can, when you say speak, it will do different things, or maybe sometimes the same, randomly, or pseudo randomly every time. Okay. Are we good on time? Yeah, almost there. So when you talk about instance variables, we already know that's attached to that instance, right? each instance will have a different like coordinate xy and fraction numerator denominator. There are different instance variables when you create different points or fractions. And then you can use self to get them. Now, there's another class of variables called class variable that belong to the whole class. Now, you may want to know why you need that thing, right? So define a class variable, you have to define outside any functions, any init function, and it's shared among all the objects of that class. So for example, if you, in an animal class, right, these age and name are instance variables. That means the age and name are different than depends on different person or animal. Okay. However, in the rabbit class, I want to tally for each new rabbit, I want to give them a unique ID, right? If you have two rabbits instance, you may not know, what ID that previous rabbit already got. But if you put this tag variable outside init function, that will be shared across all rabbits, burst from this template. Okay, so you can just simply refer to that like rabbit.tag. Remember, this is not self.tag because you use a class name .tag to refer to a class variable, and then you assign it to a instance variable self dot whatever RID, rabbit ID. So the idea is every time you assign that ID to rabbit ID, you can increment that ID by 1. And the reason you want to put it to class variable is that you may have two rabbit, requesting an ID, and they are both increment that by 1, right? I mean, I'm going to talk about race condition later, but this basically guarantee you that you want to look for the existing tag and add 1. So as long as there's no other conflict, you will get unique ID, all right? Because each object can look for the tag. The tag keep accumulating, right? So basically, it's a tally of how many animals are being produced by this template. Okay, so that's that. So basically, you added a unique tag for each rabbit born. Let's look at some example. Again, how to define a operator add, how to add two rabbit together. Well, we'll define, if you add parent 1 and parent together, you will get a new rabbit with 0 age. You will born a rabbit, right? Born new rabbit. So that's that. So in how to define that, you define a add function. You just return a new rabbit with 0 age and parent 1 and parent 2. Okay, so here's some example. Peter is a 2-year-old rabbit, and Hopsy is a 3-year-old rabbit, and Mopsy is Peter plus Hopsy. Mopsy is 0 years old, right? Its name is Mopsy. And then you print Mopsy's parent 1 and parent 2 is Peter and Hopsy. Okay, so that's how it goes. So when you want to compare, well, you can compare if two objects are equal, right? Equal. So how to compare it? Well, you can compare with the parent's name, but be careful because the parent 1 and parent 2 may be swapped, right? But they belong to the same parent. If they belong to the same parent, it should be equal. That's how to define it. And we use the rabbit ID, not the name, because the name can have redundancy, but rabbit ID don't. Okay. So parent's name, parent opposite is basically the two parents. And if the parent's the same or the parent opposite the same, that means they have the same parents. Okay. So when in using that, if the parent 1 is equal to parent 2, double equal, it will call this equal method and give you true or false. So for example, here, Peter is rabbit 2 years old, rabbit Hopsy. And Cotton is a rabbit of 1 year old with Peter and Hopsy as her parent. And the Cotton's name is Cottontail. Mopsy is born by Peter and Hopsy. And is Mopsy equal to Cotton? The answer is true because they share the same parent. All right, so again, a class is like a template, right? Object is like the house built from the template. A 3-bedroom, 2,000 square foot, 5-bathroom house. And you can bundle, object and method together in a class. Basically, you define the custom type in Python. And remember, in Python, everything is object, even the primitive numbers like integer and float and strings. Okay. So, and the way to define object and use object is totally different thing, okay? You can also build layers of object by hierarchy, right? You can inherit one object from another to save, attributes. And you can, so in that case, you can also derive your class on top of Python's own basic class, isn't it, right? So these are all the good things about object-oriented programming. So that's it, folks. I think you already know a lot of things. Let me just give you a quick summarize on what you have learned so far in this course, and what we had from this, right? We talk about a lot of Python data structure like list, tuples, dictionary. We talk about functions, classes, abstract data types. We use iteration, recursion, and we use different algorithms like searching and sorting for the computation. So basically, you not only learn the Python, hopefully you also learn how to think computationally and solve problem-solving skills. Okay. So many of you may not be in computer science major, but what computer science did, right? Some of you are. They just use the same thing you have learned in this class to do algorithms, automate things, and such, right? So what is computational thinking? It's basically problem solving, right? Using set of the data structures and algorithm to solve problems using computer programming. So when you look at this, model, you want to think about abstraction, and to basically choose the right models to represent your data. Like in the project 1, I think the key is how to use a dictionary, like this kind of data structure to represent your model, such that your follow-up method to navigate between rooms and to get Adam from the room will be very easy once you choose the correct, object. Okay. So, and we didn't emphasize a lot of like runtime, like different object can have a different way to program it, while resulting different running time. So a good algorithm is very important. So where you can head after this course, you can continue with other, courses like a data structure and algorithm course is very important. Everybody need to know some algorithms to make your programming life easier. And you can take a course in software engineering, machine learning, web programming, data science, AI. These are very big. Python is very, it's a fundamental tool for data type, data science and such. So there's a lot of possibilities with Python. So good luck, and I wish you guys all the best. Okay, thank you very much. And if you have some leftovers, please, finish your assignment and such. So thank you very much, and good luck.